Okay, so we've created some interp locations. These are scene components on the character, and we've attached static meshes to them in the blueprint just so we can move the scene components around and see where they are. Now we're ready to actually use these as interp locations. Let's get started. Now recall in shooterCharacter.h, we have a function that returns an f vector, and this function is called getCameraInterpLocation. Well, now we need to make a function that will get us the correct interp location using these scene components. Now, in order to make this easy, we can create an enum so when we pick up an item, we'll know if it's ammo or a weapon. So let's go here into item.h and define this enum for the item type. So just below our item state enum, I'm going to create a new enum. It's going to be a scoped enum, so I'm going to say enum class, and I'm going to call it item type. And it'll be based off of uint8, just like our other enums. And just like our other enums, I'm going to give it a uenum macro with blueprint type, so we can use it as a type in blueprints. And we need basically two enum constants. We need one for ammo and we need one for weapon, because those are the two types of items we have so far. So let's create a new enum constant called EIT_ammo, and we'll give this a uMeta macro, and we'll give it the specifier display name equals ammo. And we can add another one for weapon. So let's add EIT weapon, and the display name will be weapon. And that's the only two we need for now, but I'm going to add a max enum constant called EIT max, and this will just be called default max for the display name. So now we have an enum called item type, and we can go ahead and create a variable of this type for the item class. So let's go ahead and scroll down into our private section all the way at the bottom, and let's add a variable of type item type, and let's call it item type. Now I'm going to give this a uProperty, and I'm going to make it edit anywhere, so we can edit this in blueprints. I'll make it blueprint read write, and let's make it category item properties and give it the meta specifier that all our other private variables have. Now I'm going to give this a comment, and I'm going to say enum for the type of item this item is. And for the default value for item type, I'm going to go ahead and give it the default max value. So let's go into item.cpp, and just up here in the constructor, I'm going to initialize it to item type EIT max. Okay, so now item has an item type enum that we can use to know which type this item is. Okay. So now we have an item type enum on the item, and this will be ammo if it's an ammo item, and it will be weapon if it's a weapon item. Now let's go back to shooterCharacter.h, and in shooterCharacter we have these scene components, and we're going to use them for their locations so we can have interpolation locations. Now I'd like a way to keep these in a container so that we can access them easily. We would also like to know whether any items are interping to or at those locations, and if so, how many items are interping to each particular scene component's location. So we can make a struct to hold a scene component and a number for how many items are interping to that location at any given point in time. So let's go up to the top and create a new struct. So just under our enum, I'm going to make a new struct, and I'm going to call this f_interp location. Now I'm going to give this a uStruct macro and make this blueprint type. And I'm going to give this struct a generated body. That's what uStructs will need for the reflection system. And I'm going to simply give this struct two variables, a scene component and a item count for how many items are interping to this scene component's location. So I'm going to say uScene component. It's going to be a pointer, and I'm going to call this scene component. I'm going to give this a uProperty. I'm going to make it visible anywhere so we can see it. Blueprint read only. Now the next variable is going to be an int32 called item count, and this one will also be visible anywhere, blueprint read only. Now let's give these comments, and I'm going to say for scene component to use for its location for interping. And for item count, we'll say number of items interping to / at this scene comp location. Okay, so we've defined a struct to hold information for an interpolation location. It's going to hold the scene component, and it's going to hold the count for items interping to that location. Now I'm going to create an array to store some of these in. So let's go down to the private section, and we'll create a private T array. And this will be a T array of f interp locations called interp locations. And we can give this a U property. And I'm going to give this edit defaults only, blueprint read only, and we'll give it the same meta specifier. So I'm going to comment on this, and I'm going to say array of interp location structs. Now I'd like to create a public getter to get an item from this using an index. So we can basically get an item from this array, selecting it by its index. Because this is a private variable, we need a public getter if we want to get one of the items in the array. So let's scroll down all the way down to the public getters section, and let's make a function called getInterpLocation that returns an interp location. So we're going to say f interp location, it's going to return that struct, and then we're going to say getInterp location, and this will take an int32 called index. So we'll go ahead and create a function body for this in shooterCharacter.cpp all the way down at the bottom. So I'm going to copy a shooter character with the double colons and put that on the function name. Now, what are we going to do when we call this with an index? Well, first we need to make sure that our array has that index. So we can say if index is less than or equal to interp locations dot num. The number of elements in interp locations needs to at least be able to accommodate for this index. Now, if so, we can simply return the value at interp locations at this index. Otherwise, we can simply return an empty f interp location by using the f interp location constructor. We're just constructing one that's empty and returning it. That's going to have a null pointer and an uninitialized int value. Okay, so we have a getter to get an element from this interp locations, but now we need to actually add stuff into this array. And I'm going to create a function to initialize it. So let's create a protected function, and I'm going to call this, it's going to be void, and I'm going to call it initialize interp locations. I'm going to go ahead and give this a function body. And I'm going to add some things to this array. Now the first element of this array is going to be our weapon interp location. So I'm going to make an f interp location struct and call this weapon location. Now I'm going to go ahead and initialize this. Now the two variables are the scene component and the integer. For the scene component, I'm going to give this weapon interp comp. That's our scene component for the weapon interpolation location, and the second one is going to be 0, since no items are interpolating to this location when we first start. Now I'm going to take interp locations and add an element to it. I'm going to add weapon location. Now I'm creating this local variable here for clarity, just so we can see that this is a f interp location. So if you wanted to go ahead and construct a new struct right here in the parentheses, you could do that as well. Now let's go ahead and create an F interp location for interp locations 1 through 6 and add these to the array as well. So we're going to say F interp location, interp loc 1, we'll call it, and I'll initialize this with interp comp 1 and a value of 0. And I'll go ahead and just add this to interp locations using add, and I'll just add interp loc 1. And we can simply copy this and use it 5 more times. Now, for the second one, it's going to be interp loc 2. We still want to initialize it with a value of 0, but we need to use a 2. And when we add to interp locations, we need to use interp loc 2. Next, we're creating interp loc 3, and we're using interp comp 3, and we're adding interp loc 3 to the array. Next, we'll use 4, and then we've got 5 and 6. So we have this function that essentially creates new F interp locations and adds them to our interp locations array. So now our interp locations array should have 7 elements in it. The 0th element will be for the weapon interp location, and the other 6 will be for the remaining item interp locations. And we can simply call this function in begin play. So let's go to begin play, and at the very end of it, we'll simply call initialize interp locations, and I'm going to give this a comment and say create F interp location structs for each interp location, add to array. All right, so we've set this up and we're ready to use these functions. I'm going to go ahead and call it quits for this video, but just to recap, what we did was we added a new enum to the item class. We called it eItemType, which it has 2 enum constants, ammo and weapon. We're going to use those in the future. We then created on our shooter character a new struct called FInterp location, which holds a scene component and an integer for item count. This is going to be the number of items interping to that particular location at any given point in time. We then created an array of interp locations called interp locations. This is an array of FInterp location structs. And we then created a function called initialize interp locations. It creates 7 new structs and it adds those structs to interp locations. Let's go ahead and compile this to make sure it works, and then we'll go ahead and wrap this up. Okay, we've compiled successfully, so we are ready to continue this in the next video. See you then.